All right, ladies and gentlemen, we are looking at the first portion of our homework for Chapter 2. In the first portion of our homework, we were dealing with just prime factorization, making factor trees, and then we started with the commutative property of multiplication and the associative property of multiplication. What I'm writing in right now for this very first one, I gave you on your homework. So the first step is just showing the commutative property, which is moving the numbers around. The second step is taking that same equation and changing the parentheses, and that would be the associative property of multiplication, or changing the order in which we do the multiplying. So number 2, you had to set it up very similarly, except for number 2, they told you to do the associative property first. So I'm moving the parentheses, the numbers are staying in the same order, and I'm labeling it with the associative property of multiplication. And in the second step, I'm moving the numbers around. But the parentheses are staying in the same location, and that would be the commutative property of multiplication. After 1 and 2 at the bottom, we needed to do a couple of steps. The first step is you needed to make a factor tree. So for 49, breaks down to 7 and 7. Those are prime, so I circle them. Prime number has exactly 2 factors, 1 and the number itself. I'm pointing out here that it says that you need to make sure you write the prime factorization using powers. A lot of you are leaving your steps done except for you're missing the last step. So this one would be 175 is 5 times 5 times 7. And then using powers, it would be 5 to the second power times 7. You can do these factor trees any number of ways, but you need to make sure that you would have the same prime factors in your final prime factorization. Here we have 88 for the factor tree for 88. Broke it down as 11 and 8. 11 is prime. 8 is composite, so we continue to break that number down until we just get to all prime numbers. So 88 is going to be 2 times 2 times 2 times 11, or 88 is equal to 2 to the third power times 11. $108, I separated about into 9 and 12. 9, you must make sure to remember to break it down to the prime factors of 3 times 3. And for 108, we get 2 times 2 times 3 times 3 times 3, or 2 to the second power times 3 to the third power. Number 7 looks difficult, 2025. If you're able to divide it by 25, you see that the other factor, the factor pair with 25 is 81, which is kind of easy to break down. It's 9 times 9, and then each of the 9s breaks down to 3 times 3. So for 2025, we have 3 times 3 times 3 times 3 times 3 times 5 times 5. And if I missaid that, it would be 3 to the fourth power times 5 to the second power. Number 8, I saw a lot of papers where they just had a number on there, which doesn't really answer the question very clearly at all. So you might have had a right answer, but you needed to make sure that you noted that according to the directions here, you needed to break the number down, so once you broke it down, it had 3 different or distinct prime factors. So for something such as something such as 30, which a lot of you used, That's fine, but you should have showed that the prime factorization for 30 is 5 times 3 times 2. Some people just wrote a number down, and that's leaving somebody else to figure out if you have the right answer or not. And you should be explaining that you have the right answer and why you have that right answer. So another example would be 70. 70 is 2 times 5 times 7. Those are 3 prime numbers, and they're 3 different prime numbers. And that is the end of the first section. Alright, this is section 2. And so this is multiples and least common multiples. So all of these are dealing with using least common multiples to solve these problems. Multiple is basically counting by, in this case, 12s. These are in a factory. Rana is checking the different parts. And in one machine, there's one that comes out every 12 seconds, and then another part that comes out every 45 seconds. And she wants to check the parts as they're both coming out to see if they are up to specifications. Okay, so as I'm listing the multiples, I'm going back and forth between the two, and I'm looking for the first one that's going to be the same. In this case, I found it, it's 180. All right, and so Rana tests the parts every 180 seconds, and 180 seconds, well, there's 60 seconds in a minute, and so that would be every 3 minutes. And so the first way is just by listing multiples of both or all 3 numbers or all 4 numbers until you find one that is the same. And the first one that's the same is the least common multiple. You can also use prime factorization to find the least common multiple, which I'm going to do over here. First, to do a factor tree for 12, and I find the prime factorization for 12 is 2 to the second power times 3. Then I'm going to do a factor tree for 45, and that is going to be 3 times 3 times 5, or 3 to the second power times 5. Then, for the least common multiple, I write down all of the bases, or the big numbers. So there were 2's, 3's, and 5's. Then, I look at the 2's. The biggest exponent was second power. I look at the 3's. The biggest exponent was the second power. I look at the 5's. The biggest exponent was, well, none. So then I multiply those all together, and I'm going to get a 180. I'm going to get the same answer. For part B, there's 3 different parts coming out at a nearby machine, and Rana has to go over and she has to check those parts and test them to make sure that they are working and they're up to specifications. So I'm going to take the one is 8 seconds, the second one is every 15 seconds, and the third one is every 32 seconds. For those of you that came in to go over this problem, we listed the multiples, and it took a long time to list all of the multiples and not make a mistake and still get the right answer. So with bigger numbers or numbers that don't have a lower least common multiple, it's better to do the prime factorization. So in this case, I look at all the bases. There's 2's, 3's, and 5's. Then I look at the 2's. The biggest exponent for 2's is to the 5th power, so I make my LCM to the 5th power. Then I look at the 3's, just to the 1st power. My 5's, just to the 1st power. So 2 to the 5th power is 32 times 3 times 5, or 32 times 15, which is going to be equal to 480 seconds. Could divide that by 60 because there's 60 seconds in a minute, and then that is going to be 8 minutes. So on one machine, or on 2 machines close together in one section, she has to check them every 3 minutes. In 3 machines in another area, she has to check those every 8 minutes. So part C is saying, how often is Rana going to have to test both sets of parts? And so to do this one, I listed the multiples again. So I listed the multiples of every 3 minutes for the one section and every 8 minutes for the other section. And the first multiple that is the same is the least common multiple. In this case, it's going to be every 24 minutes, she is supposed to test both parts at the same time. Part D asks for you to think a little bit. Well, I can't check both parts because it's two separate parts of the shop. Okay, so which parts should she check when every 24 minutes? A sample answer is she should test the parts that she normally only tests every 8 minutes because she tests those less frequently than the ones that are tested every 3 minutes. So she's tested more of the parts that she checks every 3 minutes. So it'd make more sense to check the ones that are coming in every 8 minutes when she's supposed to be checking both of those parts at the same time, which would be impossible if it's in two separate parts of the shop.